Okay, we're going to be discussing symmetry today, whether a function is even, odd, or neither, that type of symmetry. Quadratic functions have other types of symmetry also at times, but today we are focusing only on the words even, odd, or neither. For a function to be even, it needs to be symmetrical about the y-axis, meaning that I need to be able to take the graph and fold it on the y-axis like this one is, and have the graph touch itself. So if I folded it here, I've got the same point on this side that I do on that one. My x values are opposite values, opposite x values. One's positive, one's negative, but they have the same y values. So that makes a function even. For a function to be odd, it is symmetric about the origin, which is a rotation around the origin. And I have written here, you flip it upside down. Totally take that graph, spin it 180 degrees, and if it touches itself, it's odd, like this one. And opposite x values will have opposite y values. So when I look at 1 and negative 1, my y values will be exactly the opposite. They're 1 and negative 1. Or 2 and negative 2 has 2 and negative 2, that kind of thing. That makes a function odd. If I have neither of those things occur, then we say that this function does not have any symmetry. And we say neither or no symmetry. Okay, let's look at this one. This one looks just like that first graph. Except for this graph is turned upward, that one's turned down, and also that's not working. Okay. And also, well, this one's turned up, the other one's turned down, but this one is symmetrical on y. If you look, this one has symmetry, but it's not on y. Its symmetry is right here. So if I were to fold this graph on y, it will not touch itself. So we say neither. So you can't always go by the way that it looks. All right. This function is exponential. Remember, in the 9th grade, in Algebra 1, the only functions we look at are linear, quadratic, exponential. I've shown you a quadratic function, a linear function, another quadratic function, and then now this is exponential. An exponential function never has symmetry. So if you see an exponential function, this one right here, this curve, this little L-shaped curve that's not really got a point in it, but it's like this, that is neither. It is always neither. You don't have to think about that one. It will always be neither. Your opposite x values will not have opposite y values, and nor will it have any opposite x values have the same y values. The only function that's ever going to be even is quadratic. A linear will never be quadratic. So a linear will never be even. A quadratic function is the only one that will ever be even. And a linear function is the only one that will ever be odd. And for a linear function to be odd, given the three functions that we discussed, now I'm not saying ever in the future, that and no other function will be odd. That's all I'm saying. But for the three functions that you have to know in 9th grade, the only one that will be odd is a line, and it will have to go through the origin to be odd. Okay, so that one's neither. All right, this one is neither. This is what I was discussing. This is a linear function, but it is not going through 0, 0. You cannot spin this one upside down and it land on itself. Your opposite x values do not have opposite y values. If you look here at 1, you've got the point 1, 3. If you look at negative 1, you do not have negative 1, negative 3. So that's the only way it would be odd. And it is not even because you don't have 1, 3 and negative 1, 3. It's just not there. So that's neither. And remember, this kind of function is exponential and it is neither. Now, to determine whether a function is even, odd, or neither by looking at the table, remember what I said about opposite x values and same y values. So you look and you have opposite x values, same y. Opposite x values, same y. That's even. Let's go down here and let's look at this. Opposite x values, opposite y values. Opposite x values, and they're not either. Neither one, they're not opposite, nor are they the same. So that one is neither. This one is neither. It's obvious right away. An even function is even. If you look at your opposite x values, they have opposite y values. Opposite x, opposite y. That is odd. Sorry, didn't mean to say even. That is odd. Sorry about all that. Okay. Thank you.